Hello everyone, welcome to the post-content discussion of the LeetCode contest 469. Today we will be discussing the solution for the problem A and B. Let's start with the problem A. So you are given a positive integer n. A positive integer is a base 10 component. If it is the product of a single digit from 1 to 9 and non-negative of power 10. For example, 530 and 7 are the base 10 components, while 537, 102, 11 are not. Express n as the sum of only base 10 components using the previous base 10 components possible. Written an array containing the list 10 base 10 components in descending order. If you could see this, 537 can be expanded using the base 10, so this is one possibility. And if you could think that this could be expanded with 110, so let's see once by writing some test cases here. So initially the n is equal to, so initially I would be having n is equal to 537, right? If you could expand this number, it would be 5 and 5 into 10 plus 5 into 110 plus 3 into 10 plus 7 into 1, right? So you could see that this could be 10 power 2 plus 3 into 10 power 1 plus 7 into 10 power 0. So if you put the value of this is 500, this is 30, and this is 7. So this is what the question is. They are asking to return this result um, in decreasing order. It means that we should return this like this one. So if you could take the second example, which is n is equal to 102, if you could expand this one, it would be look like 1 into 100 plus 0 into 10 plus 2 into 1. So here you can see that, so you could say that this is a not positive base 10 value, because when you find write the value here, it would be 100, it would be 0, right? This is not positive base 10 value, so we are not considering into our answer. This is 10, so it should be written like 110. So how we can do this? We can simply traverse all the digits, right, individual digits, and we will write. So let's take n is equal to 537. So in my first iteration, what I can do is I just want this digit, right. So the digit, how I can get this last digit is simple. What I can do is n into n modulo 10, then I will get this digit 537 modulo 10, which is give me 7 here. So in the next test, in the next pass, I just want to remove this 7. I want 3 here. So it means let me do one thing here. So what I can do is I can do divide with n with 10, so I would definitely get removed by remove the 3 7 here. So if I, so that's resultant would be 53. In the second pass, my number is 53. I want 3 now, so I will simply do n modulo 10, so that is 553 modulo 10 would be 3 here, right? But you can see that, so when you expand this, it would be 5 into 100 plus 3 into 10 plus 7. Okay, this is okay, but when we are going from this 7 to 3, we should multiplying a factor of 10. So I will be maintaining a factor here which is initially 1. So after first pass, I will be simply multiplying my factor with factor into 10. So my factor is now is 10, right? So in the next iteration, I will be finding the 3. I will be simply multiplying 3 with the factor, that would be 30 here my. So after performing the operation on 3, I would be going with to the 5. So I want to remove the 53. So what I can do, n is equal to n by 10, that is 53 by 10. I will be having 5 here, right? In the third iteration, so I will be simply extract the last digit, that is 5 modulo 10. We will be having 5, but you can see we need to update the factor here by multiplying 10 here, right, every time. So factor would be factor into 10. Now factor would be got 100, so I will simply multiplying this digit with the 100 here. So in the first iteration, okay, we done with all the iterations here. So the resultant array would be, so while I am traversing from the starting, I will be simply putting into my vector 7 comma 30 comma 500, right? So if you reverse this vector, then this is the answer, final answer which you want. If you could see that how much, so what could be the condition in the while loop? So while the n is greater than 0, we go on traversing, right? So in this case, You could take this case for the in the last iteration. You would find that when I am updating my n, the n is got 0 here, right? So this clearly says that while n is greater than 0, we'll go on loop this number, right? Yeah. So let's write the pseudocode. I think we don't need to write the pseudocode. It's a very simple problem. And if you could think, let's see the code. I will explain time complexity after. So I will be simply maintaining the factor base is equal to 1 year. So while I am my n is greater than 0, I already told you that y n is greater than 0. Simply finding the last digit, multiplying the last digit with the base. If it is remainder is not equal to 0, that means that when the case is having when my digit is having 0, right? Let's take this case. It would be 100, 1 into 100, right, plus 0 into 10 plus 2 into 1. So when the digit is 0, this is not valid case, so we just need to skip that one. That's why I kept that remainder is not equal to 0 here. And then go on update the n and simply multiply the base with 10 every time and reverse the answer and return this answer. So the time complexity will be big O of digits, number of digits in the n, and space complexity big O of digits, right? Okay, this is the first problem. Let's move to the second problem. The second problem is split array with the minimum difference. You are given an integer array num. Split the array into exactly two subarrays, left and right, such that left is strictly increasing and right is strictly decreasing. Return the minimum possible absolute difference between the sum of the left and the right. If no valid splits exist, return -1. A subarray is a continuous non-empty sequence of elements within an array. A array is said to be strictly increasing if each element is strictly greater than the previous element. An array is said to be strictly decreasing if each element is strictly smaller than its previous one. You can see that this test case. So this is an array. You could see that 1 comma 3 is a strictly increasing array while 2 is strictly decreasing array. If you could take the absolute difference between the first part and sum of the first part and second part, so there would be two possible splits you can observe in this array. So in the first left part is 1 and the right part is 3 comma 2, which is strictly decreasing. If you could do the absolute difference, it would be 4. So another possibility is that if you could take the left as 1 comma 3, this is one of the possibility, and the second is 2, and the absolute difference is 2. So we should return the minimum possible absolute difference, so that is 2. And yeah, this is the test case, same test case which is already discussed. Let's see how we can do this one. In this problem, if you can observe that there could be three possible cases which you can observe. Let's say if my n is equal to 2, right? So in this case you could see that there are two elements, like if the elements is 2 comma 2, and in this case you could definitely have a absolute difference. If you the single element is considered as a strictly increasing or strictly decreasing, so this is also a valid case. That means this is a single sub element. This is also called a subarray, which is strictly increasing, strictly decreasing. So if you could take this absolute difference, it would get 0. Let's check some of the case which elements are not equal, 1 comma 2. You can see that this is also a valid case. It means that this also single elements is considered as a subarrays. So in this case, the absolute difference is 1. So if n is equal to 2, then I will simply return absolute difference between the nums of 0 minus nums of 1, right? So this is one case which you can observe from this one. So sorry, this is first case. The second case is that let's say if my array is, let's say this is 1 2 3 4. So this is second case which you can observe from our question. In this case you could there could be only one possible split here. This is a possible split because this is strictly increasing, strictly decreasing, right? This consider a single element as strictly decreasing. So in this case you could see that 1 plus 2 plus 3, this is 6, and 4 as 4. If you could take absolute difference, absolute of 6 minus 4 is 2. This is the answer, only one valid answer. So we'll only having valid split. So we'll do very we can do using finding a sum of from the 0 to n minus 2, and simply subtracting this 4, right? So this is the second case. In the third case, let's say What if my array is having peak element at the middle? I mean that let's take 1 comma 2 comma 3 comma 4 2 1, right? So this is a case where we actually need to think more about this test case. So you can see that this is a valid array left array which is strictly increasing, and this is a valid array right array which is strictly decreasing. If you could think like this is a valid split, right? So one place, yeah, don't I don't want to compute the sum here, so let me do one. So 1 comma 2 comma 3, so this is one of the split for the first array, right? For the sorry, so second split would be like 4 comma 2 comma 1. So what if there is another valid split you can observe from this array? So this is a valid split, right? So you could see that 1 comma 2 comma 3 comma 4 is strictly increasing, 2 comma 1 strictly decreasing, 1 comma 2 comma 3 comma 4 strictly increasing, and 2 comma 1 is strictly decreasing, right? If you could take as x1 and s2, so you simply find the sum of these numbers, and find the absolute difference between these sums, and find this sum of this first left subarray, sum of right subarray, and find the absolute difference, and take the minimum of this, right? So minimum of s1 comma s2. So this is only a two valid case. You will, if the peak is found at the middle of the element, then there could be only one valid two valid cases you would find. So we discuss the three cases here, right? Let's see how we will do this question. So let's derive our idea, right? So first idea is that how we can. So there is another. There is some invalid arrays. How we will find this invalid array? So 1 comma 2 comma 3 4 comma 2 comma 5. So you could see that this is a valid increasing array of left side, and you could see that okay, we can do this one, right? You can see that this is a valid one. Let's take some of the example: 2 comma 3 comma 4 comma 2 comma 1 comma 5, right? You could see that this is a valid case, okay, fine. But when you are um, checking for the condition for the second array, this is not a strictly decreasing array, right? Which five here, 5 is disturbing the complete array. So this is an invalid case. We will see how we will handle invalid case here in this. So our main idea is to find the peak, right? Our main idea is to find the peak element in the array. I will take the two arrays here. So the first array is 1 comma 2 comma 3 comma 4. Second array is 1 comma 2 comma 3 comma 4 comma 2 comma 1. So my main idea is to find the peak. So if my peak is found at the last, then I would definitely say that there is only one possible split, right? One possible split. If I found my peak has in the middle, or somewhere in the middle, or okay, somewhere in the middle, then there are two possibilities. The What are the two possibilities? 0 1 2 3 4 5 are the indexes. 0 1 2 3. So we don't need to consider this case, because we if you found the peak at the n minus 1th index, we'll simply return the sum of these minus this, right? Absolute of that one. And in this, so when the case is that when I'm having peak in the middle, so there are two splits from 0 to p. So when I'm including this peak into my this left array sub array, and the second case is that when I am including this peak into this right sub array. So there are two possible ways to put this peak, right? So they are both are valid. In this case, you could see that the p minus 1, I mean p minus 1, I mean that index, and in the next part p to n minus 1, right? And in this case p plus 1 to n. So there are two valid splits, split 1 and split 2, split 1 split 2. So there are two cases which we actually need to handle in this case, right? So this is only the case which is we actually need to think about more, because this peak element is either either we first will put into the left part, and we'll see how does it contributing minimum, and again we'll put into the right part, and we'll take the minimum of both the cases. So these are the two parts. right? This is a part 1 and this is a part 2. So we'll take minimum of this one, right? So let's see how we can do this one. If you could think that, so let's see how we can actually find the peak element. It's very simple that 1 comma 2 comma 4 comma 3 comma 2, right? So how we can find, let's say I will be starting from here. I will simply asking this element, are you greater than the previous element, and we'll go on checking this element. When I will break this condition, like when I'm starting this element, I would ask are you 3 is, are you greater than 4? No, because this is my peak element which I'm storing, right? And when I got peak element, I will simply check, are you at the n minus 1 index? It means that the all elements are strictly increasing or all elements are sorted. So in this case there is only one possible split. If I found my peak at this index, then I will simply, in the first case, what I can do, I will be having sum of the left part 0 to peak. So this is okay. Let me write this case here. So my left sum would be 0 to peak, right? And right sum would be, peak plus 1. Peak is, it's indicating the index here, p plus 1 to n minus 1. So I will be having the, taking the absolute difference between the left sum minus right sum, right? And you could see that, yes, this is the one condition where I am putting my peak in the left side. So what if my peak, what, so the another condition is case 2 is that peak in right subarray, peak in right subarray, right? So how I can check that, how I can put the peak into right subarray? So that the idea is very simple, that what I can do is that I will simply subtract the left sum minus is equal to array of peak, right? That means I will be simply subtracting this element from this left sum, and I will be adding into the right sum here. Right sum plus is equal to array of p. So this is how I can make my peak in these two cases. So the last thing is that how we can check that is the array is valid or not, right? So initially we are simply finding 3 comma, let me write the case here, 3 comma 2 comma 5. So I just want to check that this is an valid array or not. So at the initially we are finding the peak element, so this is a peak element. So after finding the peak element, I will be simply traversing from p plus 1 to n minus 1. I will go on checking that this element, are you less than the less than the previous element, then it's okay. I will be going here and I will be simply checking that is it less than the previous element. Going to 5, I will be seeing previous element. You can see that 5 is not less than previous element. I will be simply returning minus 1 here. So this is how we are finding the valid or invalid array. So let's see the code. So initially I will be simply finding the sum here. So if it is n is equal to 2, this is very simple split, that each element is considered as a subarray. And the second part is that I will be finding the peak element. So the right subarray starting part would be peak plus 1, right? Let's see here. So so this is a left subarray. So the left, so this is a left subarray. The right subarray part is starting from p plus 1, right? So this is how I initialize the starting index of the right subarray. Right start is p plus 1. So the second case is that if all elements are strictly increasing, so there is no decreasing array. So there would be a last element that could be having said to be a strictly decreasing subarray, that is taking a single split, right? This could be the one split, and this could be considered as second part. So I will simply subtracting, I will be having all the sum of the all these elements, so that is 10. From 10 I will be subtracting this element, that is n minus 1. And from n minus 1, this should be considered as a single sum, and this considered as second sum, right sum. And I will be returning the absolute of these two things. And after that I will be checking the validity of the array after the peak plus 1, that is right start plus 1. So I will go on checking that is it the array is strictly decreasing or not. So if it is not, I will simply returning -1, and I will be finding the left sum, right sum, right. So this is how I will be going from 0 to peak and peak to n-1, and I will be having answer is equal to 108, because you can see that the elements are 10 power 5. If you could add the 10 power 5 elements, it could be exceed the limit of int max. That's how I took the 108 here. So the first case is that if I could keep my peak element in the left side array, so this is the first case. And the second case is that I just need to check that left is greater than 0, because if it is, if my peak might be at the 0th index, right? So that is not a valid index that I should consider here. And I will be simply putting my peak element into the right subarray. That is, I will be simply subtracting that element from the left sum, and I will be putting that element into the right sum, and I will be getting the absolute and calculating the minimum answer. If you could see the time complexity here, so we are running the big O of n loops in the 2 3 times. So here we are running big O of n in the worst case, right? So big O of n in the worst case, yeah. So at the overall time complexity is big O of n, space complexity is big O of 1 here. So thank you for watching.